All right, we're going to start today with redox reactions. My usual struggle, find it. All right, redox reactions are actually called oxidation reduction reactions. A lot of times they're called redox for short, just to make it a little easier. Another thing that we're going to be dealing with in this unit is oxidation numbers. And I'm just going to abbreviate that ON. Oxidation numbers looking at the movement of electrons from reactants to products, which are important in these reactions. So redox reactions describe any chemical reaction in which there is a net change in the atomic charge, not in the atomic number. And this change is due to transfer of electrons. So one element or compound is going to lose electrons and another one is going to gain it. So we're going to see a change in oxidation number between elements or compounds from what they originally were in the reactant to what they become in the product. We've already studied some types of oxidation reduction reactions because that is not the only way that most of these reactions can be classified. So formation of a compound from its elements. A synthesis reaction would be an example of one we've studied. All combustion reactions where you combust something in the presence of oxygen. These reactions generate electricity because there's a movement of electrons. So a lot of times these reactions are taken advantage of in the development of batteries and also then some cellular energy. Things that you may have studied in biology could be redox reactions. So like I said, the key net movement of electrons from one reactant to the other is going to be your key idea in these types of reactions. So oxidation is the loss of electrons. And since it's losing electrons, the oxidation number should increase in that element or compound. Reduction is the gain of electrons, so oxidation number should decrease because it's gaining something negative. This unit has some little mnemonics if you like them. Oil rig. So that's oxidation is loss. And then the electron is implied. So oxidation is loss of electrons. Reduction is gain. And once again, electron part is implied. If something is oxidized, which means it loses electrons, it becomes the reducing agent. It's lost electrons, so now it's going to give electrons to another element or another compound, causing them to be reduced. So it's the reducing agent. And then if something is reduced, that means it's an accepted electron, so it becomes the oxidizing agent. So whatever type of oxidation or reduction that is happening to the element or compound within the reaction, they become the opposite type of agent. So if we just look at a really quick example, this would be a synthesis reaction from elements. So the oxidation number, we'll go over this in a minute, for each of those compounds, because the oxidation number for any element in its normal state at room temperature is 0. And then over here, my fluoride is going to have a -1. My hydrogen is going to have a +1. So oxidation is what you see is happening with the hydrogen because it's going from 0 as a reactant to a +1 as a product. So it has lost electrons and it is becoming more positive. Reduction is what's happening to my fluorine. It's going from 0, but then it goes to -1. So it has gained electrons and it is becoming more negative. Since hydrogen has been oxidized, It is the reducing agent. You can see here, oxidized, opposite type of agent. Since fluorine has reduced, it is the oxidizing agent. Once again, we said it's been reduced, so it is the opposite type of agent. Now, the first bit on these is assigning oxidation numbers, which should be familiar to you because that was one of the videos that you were supposed to watch. So like I said, I'm going to use ON, oxidation number, also known as oxidation state, a little bit different from their charge that we use on our ion sheet. So it's defined as the charge of the atom would have if electrons were not shared but were actually transferred completely. So a little bit different definition that we've been working with. In a binary ionic compound, so bi means two, so an ionic compound that's metal and a nonmetal, the oxidation number is equivalent to the ionic charge. For covalent compounds or polyatomic ions, the oxidation number is often less negative. You had to do a little bit work, and it's going to be determined by a set of rules that we're going to look at, and then that you will always have on a quiz or on a test. You just need to know how to apply them. So we have some big general rules for oxidation numbers. For an atom in its elemental form, it has an oxidation number of 0. So this would include all diatomics, like I just showed in that example. If I have Fe, not the Fe ion, if I have Fe, a piece of metal, its oxidation number is 0. For a monoatomic ion, its oxidation number is a charge. So if I have sodium, group 1, sodium ion, its oxidation number is equal to +1. The sum of the oxidation numbers for atoms in a molecule or formula are equal to 0. In a polyatomic ion, the sum of the oxidation numbers is going to be equal to its charge. So if I have H2O, when I sum up all those oxidation numbers, they should be equal to 0. If I have the phosphate ion, when I sum up the oxidation number of the phosphorus and the 4 oxygen, that should be equal to -3 because that is its charge. Right, and then we kind of get into some more that are a little bit more specific. So you need to use these in order. Because you need to start at the top and move to the bottom, because if you jump down here and I don't know, try to follow this very last rule, number 6, then the other rules may not hold true. So what usually happens in a compound is there's usually a rule for 2 of the elements, and maybe there's a third one that you have to solve for, or maybe one of the elements and there's a second one that you have to solve for. So group 1, our group 1 metals are always going to be +1, group 2, +2. That hasn't changed. Hydrogen is +1 in combination with nonmetals. So that would be an example like water. It's -1 in combination with metals and with boron. We have not done a whole lot of those. So you may have some examples come up, but we don't do a whole lot of those. For fluorine, the halogen fluorine, its oxidation number is -1. Hydrogen is -2 in all compounds, except if it happens to be with fluorine, and it's -1 in peroxides. Remember, we said that's kind of a different class where oxygen carries a -1 charge instead of a -2. Once again, probably not something we're going to worry a lot about or come across. The group 7A, so these are your halogens, have a -1 in combination with a metal, a nonmetal except oxygen, and other halogens in the lower group. So most of the time it's going to be a -1. So like I said, you usually can get some oxidation numbers really easy, and then you might have to solve for one, kind of like a little algebra problem. All right, so let's just start with some easy ones. So calcium oxide, so calcium is a +2, group 2. We said oxygen is going to be a -2. So +2 is equal to -2. And if you add those two together, you get 0. So those are good numbers. That would be the numbers you would need. And the reason you need these oxidation numbers is you're going to assign them in the reactant and see how they change to the product. My next one, I have potassium, which is a group 1. I'm going to write some of these out and then I'll have to erase them as I go along. So potassium's a +1. We said the oxygens are a -2. If I have 3 of them, I have a total of -6. Since this has to equal to 0, that means the nitrogen has to be +5. Then I have a +5 and a +6 and a -5. Next one, NaHSO4, a little bit harder one. I'm going to break this up a little bit differently. Sodium, group 1, that's an easy one. HSO4 is the bisulfate ion, and it has a -1 charge. So when I add up the oxidation number for all of these, then it should be equal to -1. The things that I know is I know that hydrogen is a +1. S is going to be my troublemaker here. I'm going to put it like my X, but I'm going to leave it as S. And then we said my oxygen is -2. So -2 times 4 is equal to -8. And all that should be equal to -1 because it's an ion. So it's not going to be equal to 0. So then I'm going to do a little math, move my numbers across. I have a -7. When I subtract that 1, I bring it over, it becomes a +7, which means sulfur is going to be a +6 in this compound. Not always a +6, but in this compound it is. So I have sodium a +1, hydrogen a +1, sulfur, let me write these out a little bit better. Hydrogen +1, sodium +1, sulfur, we worked that one out to give me a +6, and my oxygen would be equal to my -2. All right. Maybe you want to stop the video and try this next one, and the ones below, give them a try. All right, I'm going to go ahead and jump to some easier ones. Nitrogen, diatomic nitrogen is going to be 0. Those are the nice easy ones. It's in its normal elemental state. So it's going to be that. Water is a -2 for the oxygen and a +1 for the hydrogen. I have 2 of those, so that's how they cancel each other out. Let's look at calcium carbonate. Oh, all right. Sorry about that. All right, let's carry on. So I think we were on calcium carbonate. I'm going to work that one out. Calcium is a +2. That's the easy one. Oxygen is a -2. So I have a total of -6. So if you work that out, you can see that carbon is going to have to end up being +4. I would have a +6 and a -6 to cancel each other out. Once again, if you're having a little trouble doing that, you can set this up as a little problem. +2 for my calcium, I'm going to make carbon my X, my unknown, and then for my oxygen, 3 times -2 would give me -6, and that is neutral, so that should all be equal to 0. So when I solve, I start off with a -4. When I add these two together, bring it across, and that's where I get my carbon is equal to 4. All right. So that next page is just showing those examples and that I already went through on that. So Now let's kind of apply this to a reaction because that's the only reason that it means anything. So if I have a reaction, I need to find out what the oxidation numbers are in the reactants and what they become in the products, and then determine what has been reduced and what has been oxidized. If you don't have something that is reduced and also that something that is oxidized, it is not a redox reaction. You have to have both. All right, these are both 0 because that's in their normal state, elemental state at room temperature. We said hydrogen's a +1 and the oxygen's a -2. All right, so that gives me all of my oxidation number. So if we looked, hydrogen went from 0 to a +1. So it was oxidized, which means it's the reducing agent. So always other type of agent. Oxygen went from 0 to -2. So it was reduced. It gained electrons. Its oxidation number got smaller, and it's the oxidizing agent. So that's how you're going to apply them. Why don't you stop the video and you can give this one a try, and then I'll come back and work through it. All right, when I start on this one, I always look, if I have an element that's by itself and then it becomes a part of a compound in a product, it's probably going to be oxidized or reduced because it's going to go to from 0 to some charge. So 0 by itself, and then over here, copper became a +2. Nitrate, NO3, is a -1 ion, and I had 2 of them. So I have a total of -2, which means my copper had to be a +2. So that's my first thing that I'm going to look at. Copper goes from a 0 to a +2. So its oxidation number increased. So it was oxidized, which means it's the reducing agent. All right, the next one, if I look at these, I can see I have hydrogen, nitrogen, and oxygen to look at and decide. Very seldom is it going to be hydrogen or oxygen because we usually use a typical +1 for hydrogen and a typical -2 for oxygen. So let's see what nitrogen is in this group. Hydrogen's a +1. My oxygen's a -2, but I have 3 of them for a total of -6, which means my nitrogen must be a +5 over here. And then over here, I had oxygen -2, but I had 2 of them. So it is a total of -4, which means my nitrogen had to be a +4. So my nitrogen went from +5 to +4. So it looks like it gained one electron. It was reduced. It became a little bit more or less positive. So it is the reduced species, which makes it the oxidizing agent. All right. And then the next one at the top of that page is just going through that example. I'm going to pull up the homework or the practice, I'm sorry, hopefully. And we can see if we can look at a couple more of those. All right. Chemistry. All right, this is just all oxidation numbers. So I'm going to look at a couple of here. All right, so if I look at this, this is an easy one because it's all ions, so it has my charges. Chromium went from a +1 to a +3. So it increased its oxidation number. So it is the one that is oxidized. If it's oxidized, it becomes the opposite type of agent. Once again, 10 + 4, that's what it's telling me, and it goes to a +2. So its oxidation number decreased. So it is reduced. which makes it also the oxidizing agent. Remember, they become opposite. If it's a reduce, it's the other type of agent. If it's oxidized, then it's reducing agent, okay? And you should write what is in the reactant. So if you notice, I wrote the CR with the plus and my SN with a 4+. All right, I'm going to come down and let's look at number 5. I was trying to find one that had a little bit more work in it. Some of those at the top are pretty easy. So let's look at this one, number 5. All right, so once again, this is 0 by itself, and then it becomes part of a compound. I know that it's going to change. It can't be 0 in a compound. So that alerts me to the fact that carbon is going to be either oxidized or reduced. So my oxygen's a -2, but I have 2 of them for a total of -4, which means my carbon has to be +4. So my carbon went from 0 to +4. So its oxidation number increased. So it was oxidized, which makes it the reducing agent. Now I got to go through the whole process again and try to figure out my other one. Once again, hydrogen, sulfur, oxygen, it's probably going to be the sulfur. My hydrogens and oxygens are usually pretty typical of a +1 for the hydrogen and -2 for the oxygen. So hydrogen's a +1, but I have 2 of them. So I have a total of +2. Oxygen's a -2. I have 4. So that gives me -8. So that means my sulfur has to be a +6 to even that out. And then over here, I need to figure out what my sulfur is. Oxygen right here, -2. I have 2 of them for a total of -4, which means my sulfur has to be +4. So my sulfur went from 6 to +4. So it was reduced. So I'm going to put S for sulfur. And if it was reduced, then it is the oxidizing agent. Alrighty, so y'all have some practice on that. And tomorrow we will start with the balancing of redox reactions. And it is a little difficult if you don't, especially if you don't do any of your practice. So we will have a quiz over this portion of the notes on Friday when I get all of y'all back in class. Y'all will have a time before then to be in class with me to ask questions for that quiz. And it will be open notes, so there will not be any requiz. If you have any questions and you don't see me today because of our real weird schedule, you can always message me in Sports U. And I do have tutorials after school today and tomorrow morning. All right, see you soon. Thanks.